Hello guys, welcome back to my YouTube channel. Today's subject is all about the data structures and its applications, and the main topic is about pointers and double pointers. To begin with pointers. A pointer is a variable that stores the memory address of another variable. Instead of directly storing the actual value, a pointer points to the location in memory where the value is stored. This capacity provides a powerful mechanism for efficient memory management, data manipulation, and dynamic memory allocation. Pointers are even used to manage memory and to work with the data at a low level, providing a way to directly interact with memory locations. Declaration of a pointer. Declaring a pointer does not allocate memory for the variable it points to. It only specifies the type of data that the pointer will be used to access. To make a pointer point to a specific memory address or the variable, you need to initialize it with the address using the address of operator, which is an ampersand. In the following picture, we can clearly see that the pointers are declared as type, which is data type, followed by an asterisk symbol, then variable name. And the example given here are about the integer, character and void, which is followed by the star operator and the pointer name. Next is the initialization of a pointer. Here hashtag include stdio.h is a library function in which in main method we are going to declare a variable which is int of x equals to 10. Then declare a pointer and initialize it with the address of the variable, that is int star ptr is equals to ampersand of x, which holds the value of the variable. Next is access the value at the memory location pointed to by ptr. Printf statement here is used to print the statements, which is value of x modulus d slash n. Here slash n is used for the new line and star ptr it holds a memory location pointed to by the ptr. Then return of 0 followed by the closed parenthesis. Here the star operator is used for dereferencing, meaning it retrieves the value stored at the memory address pointed to by the pointer. And the whole program can be simplified in a single sentence, which is int star ptr, which is equals to ampersand of x followed by a semicolon. Next, let us have a look on the example for the pointer. Here again hashtag include stdio.h is a library function, and this program is about how to swap two numbers using pointers. So let's begin with the first line of code, that is void swap numbers int star a int star b. Here the swap number function takes two integers. One is int star a and the other one is int star b, and these both are parameters. And inside the function, the values pointed to by a and b are swapped using a temporary variable. Here, the second line of code here is int temp equals to star a equals to star b, and star b is equals to temp, closing of the parenthesis. Here, a tmp is a temporary variable. The next is the main function. The main function declares two integers num1 and num2, and it prints their values before and after the swap. That means here integer main int of num1 equals to 5, int num2 equals to 10, and the print statement is used, and in that print statement we see before swapping what is the value of num1 and num2. Then after passing the address of num1 and num2 the swap number functions, swap numbers and the as ampersand symbol is used for num1 and num2. With the printf statement, again after swapping what is the value of num1 and num2, returning of 0 and then closing of the parenthesis. This is a complete example for the pointers. Next, what is a pointer variable? A pointer variable is a special type of variable that stores the memory address of another variable. Instead of directly holding a value, a pointer variable points to or it refers to the memory location where a value is stored. This allows for indirect access to the value through the pointer. Let us have a look. Here the int main method function is opened with the following parenthesis. Int x equals to 10. Here an integer variable is declared. Then again int star ptr followed by semicolon. This is the declaration of an integer pointer variable. Then ptr equals to ampersand of x. This ampersand of x holds the memory address. Then returning of 0 and closing of the parenthesis. Next, we are going to discuss about passing arguments by value. There are two types of passing arguments. One is by reference and one is by value. Passing arguments by reference is the example given earlier, which is swapping of two numbers. In this slide, let us discuss about passing arguments by value. So here again, hashtag include stdio.h is the library function. Here we are going to add two numbers and print the result. Again the same, void add numbers int a comma int b. Here int a and int b are the two parameters. Then int of sum equals to a plus b, where the print statement is used to print the sum of the numbers. Int main, here the main function is opened where int number is declared with 5, number 2 is equals to 10. Then we call the function and passing value by value method. Here add numbers num1 comma num2 is used. Then original values will remain unchanged in this. Then the print statement will be original values of num1 equals to num2 equals to num1 comma num2 followed by a semicolon. Again returning of 0 and closing of the flower brackets. Here the sum will be 15 and the original values here remains unchanged. As it is unchanged, the number 1 will be 5 and the number 2 will be 10. Here we had a look on passing arguments by both reference as well as the value. So let us head on to the next topic, which is double pointer. A double pointer is a pointer that stores the memory address of another pointer. In other words, it is a pointer to a pointer. Double pointers are often used in situations where you need to manipulate or modify a pointer itself, not just the value it points to. So the syntax goes like this: data type double star pointer name. Here the data type specifies the type of data the pointer is pointing to, and the pointer name is nothing but the name given to the double pointer. And again, int num equals to 10, int of star ptr, which is ampersand of n. This ampersand of n holds the address of number, and ptr is a pointer to an integer. In the next line of code, int of double star equals double ptr. Here double ptr is nothing but a double pointer, which is equal to again ampersand of ptr, which holds the address of ptr. So initialization and declaration of double pointers. The declaration of pointer here are two data types, data type 1 and data type 2, followed by double stars, which is double pointer semicolon. And the initialization of pointers will be data type 1, data type 2, star pointer 1, where the first pointer is declared, and then again data type 1, data type 2, double star, double pointer, which holds the address of the pointer 1. Again, the example for the double pointer here is nothing but hashtag include stdio.h, hashtag include stdlib.h. These are the library functions. Here we're gonna function to dynamically allocate memory for an integer. Here we are allocating memory dynamically. There are two types of memory allocation, where it is static memory allocation and dynamic memory allocation. In dynamic memory allocation, we can change the size of the array or pointer or in an integer. So let's start with void allocate integer. Here the allocate integer functions takes a double pointer, that is int double star double ptr. So inside that function, memory is dynamically allocated for an integer using malloc. To increase the size, malloc function is used and the size of the integer value is used, and the value here assigned is 42. Then we open the main function and it declares a single pointer, that is numptr, and initializes it to null. So in this code, int star numptr equals to null. The next thing is calling the function and passing the address of numptr, which is allocate integer and ampersand of numptr. Here the function allocate integer is called, passing the address of numptr using the address of the operator ampersand. Now, how will the accessing the value allocated by the function? Printf, the value allocated by the function modulus d slash n, which is the star of numptr. After the function call, the value allocated by the function is accessed and printed. And next we are freeing the dynamically allocated memory. as it should be done explicitly only. So it is allocated using the free function, which is numptr, then again returning of 0, closed parenthesis. So what are the main objectives of pointers? The main part is about the dynamic memory allocation. Pointers are essential for dynamic memory allocation. They allow programs to request memory from the heap at a runtime and providing flexibility in managing memory resources. This is particularly used for handling data structures of varying sizes and adapting to changing program requirements. As I have already said you, it is it allocates memory during the runtime, due to which the size of it can be changed. The second part is about the efficient function parameter passing. Pass by reference using pointers allows functions to modify the value of variables outside their scope. This eliminates the need to return multiple values from a function and improves performance by avoiding unnecessary copying of data. The third main objective of the pointer is about string manipulation. Strings in C are typically represented as arrays of characters and pointers. It plays a crucial role in string manipulation. Pointers enable efficient navigation through characters in a string, making operations like concatenation and comparison more straightforward. Pointers are fundamental for implementing complex data structures such as linked lists, trees, and graphs. These structures rely on dynamic memory allocation and interconnected nodes, which are effectively handled using pointers. Pointers provide a way to directly access and manipulate memory locations. This enables efficient handling of data structures and direct interaction with hardware, making it crucial in systems programming and embedded systems. Thank you guys. Stay tuned for more such videos. Please do like, share and subscribe.